All right, we are continuing our notes on trig. Today we're looking at trig applications, which really means word problems. So if you need a little reminder at the top for your SOHCAHTOA, and it looks like I'm going to need a new writing utensil. There we go, SOHCAHTOA for our sine, cosine, and tangent. So with these, we're going to have to draw a picture to help us determine which of those ratios we're going to use to solve the problem. So two new terms you're going to need to know. Angle of depression. This is in reference to always a horizontal. If I am looking below, that would be angle of depression. And then the angle of elevation would be, again, if I'm looking at my horizontal, above. So in this picture here, if this was the horizontal, angle 2 would be an angle of depression. Here, if this is the horizontal, 1 would be elevation, 3 would be depression. And then down here with this horizontal, 4 is an angle of elevation. So that just refers to always in reference to the horizontal, are we looking up or down? So let's jump into this first example here. When the angle of elevation to the sun is 52 degrees, so that means, again, with the horizontal, if I'm looking up, there is my sun, and that makes an angle of 52 degrees. I've got a tree that's casting a shadow. So trees stand up vertically, so I'm going to draw my tree here, and that means its shadow is going to be horizontal, so that's the 9 distance. So what is the height of the tree? Well, that's going to be this vertical distance here. So with my reference angle, I want to know the opposite, and I'm given the adjacent. So opposite and adjacent tells me that I'm going to be using tangent. So I want the tangent of 52 degrees, and that's going to be equal to x over 9. So to solve this, 9 times the tangent of 52 is going to give me my x value, and we're going to round that to the nearest tenth of a meter, which is 1 decimal place, and I get 11.5 meters. Okay, moving on to the next one, we've got a person snorkeling that sees a turtle on the ocean floor. So my horizontal is going to be the ocean. And if this is my person snorkeling, they are looking down at this little turtle. And that angle of depression is 38 degrees. She is 14 feet above the ocean floor, so that's referring to that vertical distance here. And we want to know how far she is from the turtle. So that would be if I was drawing a straight line between them, so that's going to be my hypotenuse, and that 14 that I know is the opposite, so this tells me to use sine. So the sine of 38 is going to be equal to 14 over x. To solve this for x, first I'm going to need to multiply and get it out of the denominator. Then I'm going to have to divide both sides by the sine of 38. So this is what I'm going to type into my calculator, and we want to round our answer to the nearest foot, which means a whole number. And that's going to be about 23 feet. Okay, on the third one, Jared is standing 12 feet from a rock climbing wall. So here is Jared. Here is my rock climbing wall. He is 12 feet away. He looks up to see his friend ascend the wall, and the angle of elevation is 56 degrees. So from his line of sight to that friend up on the wall is 56 degrees. And there's a 5-foot distance from his eyes to the ground, and that's going to come into play later. So we want to find out how high up the wall his friend is. So again, we're talking about vertical distance here, so that would be my x. This horizontal here is the adjacent side, the vertical is my opposite, so that tells me I want the tangent of 56, which will be equal to x over 12. So I'm going to multiply both sides by 12 in order to solve for x. And we're rounding to the nearest tenth, which means 1 decimal place. And 12 times the tangent of 56 gives me about 17.8 feet. But that is just from Jared's eyes to his friend. So we have to also account for that extra 5 feet of distance from the eyes to the ground. So my actual total height is going to be 22.8 feet. Wrapping this up on the back, Maria is looking out a 17-foot high window and sees 2 deer. So here is my window, here's Maria. She is 17 feet above the ground, and she's looking at some deer. The angle of depression to the deer is 26 degrees. So if that's my line of sight, looking down at the deer, this is the 26 degrees. What is the horizontal distance from Maria to the deer? So that is my adjacent side, and that 17 that I know for my vertical height is the opposite. So this tells me that, again, I'm going to be using tangent, and that's going to be 17 over x. So first I'm getting x out of my denominator. Then I'm going to be dividing by the tangent of 26. And this problem says we're rounding to the nearest foot, which again means a whole number. And that is about 34.9 feet. Which of course would be helpful if I round it correctly to the nearest whole number, which would be 35 feet. Okay, Stickman is standing on top of a building. So here is my building, here is Stickman. And he turns and sees a taller building next to him. He sees the top of the building with an angle of elevation of 62 degrees and the bottom with an angle of depression of 70 degrees. So there's his line of sight. That angle of elevation to the top is 62, the angle of depression to the bottom is 70, and he knows that the buildings are 50 feet apart. So that's the horizontal distance here, 50. So we want to find the total height of this building. Well, my vertical height has been kind of split into two parts. So I'm going to call this part x and this part y. If I can find x and y, all I would need to do is add those two together. So starting with x, that's my opposite, 50 is my adjacent, so I'm going to use tangent of 62 to find my x, multiplying both sides by 50, and rounding to 2 decimal places. For that first height, I am going to get 94.04. Then moving on to y, y is the opposite, 50 is the adjacent. So again, I'm going to use tangent, but this time it's for 70. So 50 times the tangent of 70 is what will give me my y value. And again, rounding to 2 decimal places, that is 137.37. So when I add those two together, my total height is going to be 231.41 feet. And then last but not least, Jaden is leading a 30-foot ladder on a wall. So here is my wall, here's the ground. There is my ladder, and the ladder is 30 feet long. And it's forming an angle of 65 degrees with the ground. So here's the ground down here, which means that is my angle. How high up the wall does the ladder reach? This is the distance I want to know. Well, that's the opposite, and I'm given the hypotenuse, so that tells me I'm going to use sine, and that will be equal to x over 30. So to solve for x, I'm going to multiply both sides by 30. So this is what I'll type in my calculator into the nearest hundredth of a foot. That is 2 decimal places. We get 27.19 feet. And that wraps up our 9-10 notes, and we are now done with chapter 9 finally.